We will now move on to our next speaker, who unfortunately couldn't come today in person. This is Pippa Moore. She's a professor of ecology from the University of Newcastle, but she was able to send us a recorded presentation, so I will just ask Luke to play that now. Brilliant, thank you.
Hi, I'm really sorry I can't be down with you today. Unfortunately, some things kept me up here in Newcastle. But I'm really pleased to be able to talk about some of the work that I was involved in as part of the EcoStructure project, and very much in terms of sort of providing the evidence base for the sort of positive biodiversity outcomes from marine artificial structures. So I'm talking to an audience that doesn't really need to know this sort of thing, but we all know that there is an increase in the amount of artificial marine structures going into the marine environment, either in coastal waters such as seawalls and riprap breakwaters, through to offshore renewable energy devices. And this is commonly called coastal sprawl. We also have lots and lots of evidence to suggest that these marine artificial habitats often provide poor quality habitats for marine biodiversity. They support generally lower levels of biodiversity compared to natural rocky reefs, and often support communities that have a high abundance of non-natives. And so as a function of this, there has been a move towards looking at ways that we can make hard artificial structures better for nature through the process of eco-engineering. And over the last 10 years or so, there's been a large expansion of this work experimentally, from looking at sort of micro scale changes in texture up to macro habitat units, and looking at how they alter the biodiversity of systems. And in general, the evidence suggests that most of these interventions have a biodiversity benefit. And part of some of the work that was led by Ali Evans during her PhD, we looked at the sort of barriers to the implementation of eco-engineering within UK systems. And we felt that there was sort of three pillars that were impacting our ability to sort of see the more widespread embracing of eco-engineering in marine systems. The first pillar we saw as being a policy pull, but we're seeing these sort of change in the sort of 14 years or so that I've been involved in eco-engineering. So in the UK Marine and Coastal Act, for instance, it suggested that marine planning should avoid harm to marine ecology and biodiversity, and provide opportunities for building in beneficial features. We've found as you go through the more devolved plans for our marine systems, that some of these proposals become even stronger. So the draft Welsh Marine Plan talked about proposals should be demonstrating how they contribute to the protection and restoration and enhancement of marine ecosystems. They also went on to talk about how the enhancement of marine ecosystems doesn't need to be too complex and can involve small changes to intertidal structures, such as allowing for the formation of crevices in walls or pools at low tide. So very much emphasising that people should be considering about eco-engineering. And we're seeing that has resulted in, for instance, the Welsh Government asking us to create a sort of example, a case study on sort of eco-engineering for the marine area statement. We can see in places like Sydney with the Living Seawalls programme that there's a lot of government push for the inclusion of that. And indeed, they made the finalists of the Earthshot Prize last year in its inaugural year. We feel that there's an increasing policy pool, and we're seeing that with our own experiences where regulators are coming to us or suggesting that people should come to us to talk about this. The other pillar that we found from stakeholder meetings is there was a general feeling of a lack of an evidence base. And I guess as researchers, we were somewhat surprised at that, because actually over the last 14 years, there's been a wealth of studies looking at different eco-engineering techniques. But in this sort of little montage that I've shown here, it's very clear that most of these papers are being led from researchers, and many of them are locked behind paywalls in scientific papers that people can't get access to. So one of the outcomes from Ali's PhD that was published in this paper in Marine Policy is that we needed to provide an evidence-based catalogue of products that were out there so that we could translate the scientific evidence into something that was accessible to all. So via the EcoStructure project, one of the key aspects that we wanted to cover was actually translating a lot of the science that's out there into a format that was accessible to regulators, to industry, to interested people, so that they could look at what interventions were out there and their sort of success. We deliberately chose conservation evidence as a place to hold this, as they follow quite prescribed rules on how you actually look at that evidence base, how you describe that evidence base, and it's also an ongoing live website. So while we've created this enhancing the biodiversity of marine artificial structures, we know that evidence is continuing. And this could be updated in future years to take into account the latest evidence out there. I'm going to talk a little bit about this in the slides after here, but I'm going to stop speaking for a moment and let you listen to a lovely Welsh accent describing what we did.
Artificial structures are spreading around our coasts and seas to support growing human populations and marine industries, and to protect coastlines from rising and stormier seas. These structures can damage natural habitats and provide stepping stones for non-native or nuisance species to move into new areas. They also provide new artificial homes for seaweeds and marine animals. However, they often don't support the vibrant variety of marine life found in healthy and productive natural reef habitats, because they are simpler in shape and can be highly disturbed by human activities. Some artificial structures can be designed to make them more like complex natural habitats, which in turn attracts more marine life. This can include rare and charismatic species or commercial stocks of fish and shellfish. We can also seed or transplant species onto structures to give them a head start. These actions are called eco-engineering. Environmental managers are eager to see eco-engineering put into practice on new and existing marine structures, but they need to know their actions will have the desired effect to justify additional time or costs and to avoid the risk of greenwashing construction projects. Ecologists and engineers around the world are working to design and test eco-engineering actions to enhance the biodiversity of marine artificial structures. Based on their results so far, we have produced an evidence-based resource to help people create and manage structures that are better for biodiversity. Using methods developed by the Conservation Evidence Project, we collaborated with experts and searched scientific evidence from around the world. We found 43 actions that could be taken and 176 studies reporting their effects. We summarised each study in a short paragraph describing the action and the outcomes for biodiversity. We also indexed these outcomes in a set of key messages for each action. You can download the synopsis of evidence from the Conservation Evidence website or search the online database to find the evidence most relevant to you.
So that was a short piece that we did to launch our review of the conservation evidence. As the little video says, we created or identified, 43 different interventions or actions. And when I talk about interventions or actions, we can see some of the list here, but it's sort of like creating textured surfaces or creating rock pools is what we would term an intervention or action. So we have this list of 43 different interactions. And what became incredibly clear is that there was a lot of context dependence in terms of the success rate of these things. So it's very hard to create a one-stop shop where you can just create some drop-down menus and say, you know, what you've got and then come up with a solution. But I think the thing with this conservation evidence is that it sort of is a bit like a Russian doll. You can sort of take the top level of information and the key sort of parts and then look at the summary document and then go right down into them. One of the things that we found is that there's actually some general gaps in the knowledge. And most of these were actions on subtidal structures, also tied in effects on actions in intertidal structures. And for 10 of the 43 actions that we identified, there was zero evidence to support them. Of 24 of the actions out of 43 had perhaps less than 5 studies. So while there's a burgeoning amount of research, on eco-engineering is that when you actually start to drill down into the data, which sort of happens with any review that you do, is that you find that actually perhaps the evidence base isn't as detailed as you might have liked. Here we can show that, we found 118 different studies for these different actions in the intertidal, but only 58 in the subtidal. And you can see some had quite a bit of research on them. So things like intertidal rock pools and intertidal pits, subtidal material type, but then there's a series of actions that have nothing on them. What we did find is that many of these actions do have biodiversity benefits, and all of these actions in at least one case probably had a biodiversity benefit, but it's actually not as simple as I said earlier, as having a drop-down menu. It does mean that whoever's using this resource needs to actually sort of interrogate it a little bit. So as part of this, that we've provided some advice. So as someone who's setting out to actually look to enhance a marine artificial structure via eco-engineering, is that you really want to determine your objective in advance. Do you simply just want to improve biodiversity, or is it that you want to improve some sort of ecosystem function such as water quality, and that will dictate the sort of species that you're interested and the interventions that are likely to work? What are your limitations? At what height on in the intertidal or subtidal is this intervention being placed? There's financial limitations quite often as well, so there's a range of different limitations that will come to play. You need to understand the environmental context. Sydney Harbour, for instance, has a lot of interest in eco-engineering because an awful lot of Sydney Harbour has seawalls on it. Sydney Harbour is a somewhat sheltered harbour, so that might not work on a exposed coastline in the sort of temperate environment or cool temperate environment in the United Kingdom. And you also want to think about what might be preventing your structure from achieving its conservation objectives. Many of these structures are placed in urban environments where existing stresses that may have reduced the population of those species you're trying to get back have probably led to their demise. So can you reduce those stresses as well? Once you've looked through the different actions, if you think one of these actions could help, is read the key messages. What were the effects that were previously resulted in from these interventions? Were the species, location, context similar to you? So for instance, if you're looking at rock pools in a tropical area, you might find that they're quite stressful environments in the tropics where you've got a lot of evapotranspiration, but actually in a temperate environment, it might be that they have strong biodiversity benefits. So very much think about the context in which the work was done. Choose the studies that are most applicable to your system. Read the full summaries, which follow quite a prescribed wording, and there's explanations on what that wording means in the front material of the PDF that you can download. And also read the original studies. I mentioned that a lot of these original studies are hidden behind paywalls, but as academics, we're all rather arrogant people, and we love it when people email us asking for our research. We can then just send you a PDF and you can look at those original studies. What I would say is that the actual conservation evidence text itself is quite accessible. So you can get a lot from this sort of Russian doll approach. And then you want to assess the strength of the evidence. Generally, the longer something is monitored, the better it is, because it will have gone through perhaps periodic storminess or other disturbances. Potentially think about the experimental design and how robust it was. And how did they measure success? Authors quite often give information on what their own success levels were. And select actions for your objectives. So choose those actions that would meet your objectives, and there's evidence to suggest that they do meet your objectives. And one of the really nice things about the conservation evidence is it does follow these really strong protocols. Ali Evans in the top left-hand corner really led on this research, but also Bill Sutherland from Conservation Evidence was a key role, and Louise Firth, who's been working in this area for a very long time. It also involves people, an international advisory board who peer reviewed all of this. So you've got confidence in the work that's actually being presented there. I would encourage you that this is quite a nice bit of research to use, and perhaps something you might want to consider for your own systems. The other pillar that briefly I'll say is about stakeholder support. When I first started working in this area about 14 years ago, people weren't interested in at all about making sort of these seawalls better for nature. But we're increasingly seeing companies at startup, but also encouragement from, in our case, we've worked closely with Port of Milford Haven and also Natural Resources Wales that funded these eco-engineering interventions in Milford Haven. And also there's other projects funded by other people. I'll leave it there now. If you want to ask any questions, do please feel free to email me, and thanks for listening.